VSC, this is LFC.
VFC, go.
This is sequence 10, step 002. H2 tank subassembly number 3 simulator. Mike Victor 201, open counterclockwise.
Verify, open counterclockwise.
Mike Victor 215, open counterclockwise.
That's verified, open.
It's not enough, said Einstein, to understand science and apply it to our problems. The creations of our mind should be a blessing, not a curse to mankind.
Verify, counterclockwise, fully open.
Sequence 07, step 039, mid-fuselage coolant servicing panel. Tango Alpha 4541-004 Alpha and Tango Alpha 4541-004 Baker. Mike Victor 413, open counterclockwise.
Open counterclockwise and verified.
In the midst of your diagrams and equations, Einstein cautioned, never forget man. In this urban, crowded, hungry world, this technological age facing the shock of the future, where are the equations and the diagrams for people? Man has always been driven by his dreams to reach beyond himself. Watch towers in Los Angeles. Bits of broken glass, scrap tile, salvaged metal, the refuse of a city transformed by one shy, inarticulate man, Simon Rodia. All men dream, but not equally, said T.E. Lawrence. Some dream at night and find it vanity. But the dreamers of the day may act their dreams with open eyes to make it possible.
All still go at this time. Neil Armstrong reported.
Here in Florida at the Kennedy Spaceport, the ancient dream of traveling in space became reality.
T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff.
Let's take a ride on a rocket and sail, sail, sail. Let's take a ride on a rocket and weather most any gale. Now hug me and squeeze me with all your might and whisper and tell me you're mine tonight. Let's take a ride on a rocket and sail, sail, sail. I'll never care what the season may be, December, May, or June. All troubles and care mean nothing up there, so listen to me, Mr. Moon. Let's take a ride on the rocket
And so we reached the moon. But it was Arthur C. Clarke who pointed out, even before the first mission, that Apollo vehicles were obsolete. We cannot, he said, continue to carpet the Atlantic seabed with Saturn V's.
Rockets are really expensive. What happens to a rocket after they get up into space and they do what they're supposed to do? What happens to them? Yes.
They come apart?
They come apart. Does much of it come back to Earth ever? Danny?
Yeah.
Some of it comes back, but what happens to most of it?
Then it might, get burned up.
Something really exciting is going to happen, or is happening right now. It isn't flying yet, and it's not going to take the place of a rocket, but it's going to be something like a rocket, and it's not going to be as expensive. Does anyone have any idea of what it might be?
Oh, a space shuttle?
Yeah. What's a space shuttle? I just learned about this myself just the last few weeks. What on earth is a space shuttle, Tim?
It's a thing that sort of looks like a plane, only it's like a rocket, only it has wings and everything.
All right. And how is it going to help man in space? What will it do?
It could go up and take pictures of other planets, and so people could learn a lot about science and everything.
Crafted by hand to the precise tolerances of advanced technology, components of a new vehicle to thrust man and his instruments into space and fly them back. The work of men and women whose skills are a basic resource for all on Earth today. Countdown. Blast off. Trailing fire like any rocket, big as a commercial jet, the shuttle rises from its launch pad. After liftoff, the booster rockets separate. They are recovered and used again. The main fuel tank then also separates from the orbiter. Used on a regular, almost weekly schedule, the shuttle will be many times less costly than the rockets we now use. And the shuttle will make possible missions we cannot now perform. Man in space. Impressions of strange and graceful spacecraft, of a blue and fragile Earth. Images on our television screens. The spectacle is over for a time. How will space benefit us when we return there? Space is new and alien. Familiar things change. There is weightlessness, great fun for those who experience it. To the engineer, the scientist, weightlessness is a condition to be studied and put to use. How do the basic building blocks of life behave in zero gravity? And more complicated forms of life we can carry into space. What about man? How do fluids and materials behave in space? We can form more perfectly spherical ball bearings. We can make welds impossible on Earth. And for electronic systems, more efficient, large crystals. New compounds, new products. There are few limits to what we can do. In the old German city of Bremen, the past and the future come together. Space transportation is international. Within the European Space Agency, 10 common market countries came together to design and produce a payload for the space shuttle, this European Space Laboratory. The ESA Space Lab is Europe's investment in the future. Carried into Earth orbit by the space shuttle, it will be an observatory, a platform, and a workshop. Men and women, Europeans, Russians, Americans, engineers and scientists, people who will test, observe, and try. Astronomy, Earth observation, atmospheric studies, biomedicine, manufacturing. Like the shuttle, this modular spacecraft is reusable. Who can say what may result? New vaccines developed in space? Orbiting space hospitals where weightlessness would benefit heart patients and burn victims? Space has already changed medicine. Whittier Presbyterian Hospital in California. Here, vital life signs of premature babies are monitored, just as those of the astronauts were in space, discovering any critical shift much sooner than before. The Space Lab, of course, is only one of the cargoes that will be carried by the shuttle. A whole range of payloads can be deployed and serviced in orbit. Satellites for communications, navigation, or military surveillance. Satellites for weather observations and for the study of Earth resources. and of ecological and other major problems facing man on Earth. The Space Shuttle is the most cost-effective space transportation system possible today. It may have as great an effect on us and how we live as trains and cars and planes. The romance of getting from here to there. An old train, a coach and four, sailing ships, horseless carriages, and flying machines. We have never surrendered any of them to time. We have always been profoundly influenced by the way we move people, things, ideas from place to place. Every increase in range and speed bringing us revolutionary change. And always there were those who said it wouldn't fly. It could never be done. A passionate envy of birds, a longing to fly, and, at last, the final reaching for wings. Flight, the most revolutionary of all forms of transportation, shrinking time and space. We've always remembered the first to master this new dimension, the Wright brothers, Lindbergh, Amelia Earhart, and the rest, and their strange machines of canvas, wire, and wood. But even in 1920, a Dr. Robert Hutchins Goddard dreamed of more, of ascending to space from the meadow at his feet. He called his dream a method of reaching extreme altitudes. From space, man sees his planet Earth as a total system in which everything is related to everything else. Our instruments interpret what we see. Our beginnings and our future encompassed in our present. The Earth, its resources, the highest accomplishments of man, belong to all, to modern and to early man who still survives. In tribal Africa, in the boroughs of New York, we exist in simultaneous, identical necessity and hope. In today's crowded world, there are more and more people to be fed each day. Food crops can be monitored, protected by satellite observation and measurement, and the world's food supply increased. Weather. Destructive storms like hurricanes are no longer totally unpredictable. Their approach can be observed from space, their phenomena studied and analyzed. And with the warning time satellites give us, lives are saved. From space, we can spot forest fires, discover and treat crop and plant diseases, mark the patterns and effects of smog. From space, we can better observe the sun, ultimate source of all our energy. And we can also survey, explore, discover new deposits of fossil fuels, new energy sources to meet our growing needs. Coal, uranium to fuel reactors, other alternate sources of energy. Our view through earthbound telescopes is limited. From space, we can see more with greater accuracy. A space telescope to be shuttled into orbit will extend our view beyond the limits of the known, bringing to man more knowledge of the nature, shape, and basic processes of the universe, of pulsars, quasars, black holes, and other mysterious objects, unlocking perhaps the secret of nuclear fusion to give us boundless energy on Earth. From its missions, the shuttle will return, gliding home in unpowered flight. It will land on a runway like any cargo plane.
Hand controller's preset for 2 degrees per second. Stopping roll, coming back to the right. Stopping roll.
The flight procedures, glide slopes, landing
Runway
profiles are being flown today
Coming to the right a little bit to get lined up.
by
with the
test
runway.
pilots and simulators. From our past experience, we know that one day all these procedures will be routine.
2,000 feet, starting to flare. Landing gear armed. Landing gear down.
Men will be accustomed to blasting off into space on regular missions with payloads and passengers. Men, women, scientists, technicians, observers, shuttled into orbit. We will be used to the idea of orbiters shuttling back to land on Earth.
There's touchdown.
And in 2 weeks' time, turned around, reloaded, and ready for launch again. Launch Complex 39 in Florida. From here, Apollo lifted off to reach the moon, waiting now, like us, for things to come. The space shuttle, space stations, colonies in space in which tens of thousands of people may one day carry on the life, the work, the civilization transported from the Earth. But to what end? Will we design a future in which our technology is dominant, shrinking us to insignificance? Or a future that will open to us an ever-widening expanse of knowledge and of our essential nature, our humanity? It is up to us and to the people of that future to say how that will be. But this new transportation system, the space shuttle, is here.
This is sequence 07, step 042, hydrocarbon analyzer. Monitor meter until 500 ppm is reached.
Roger, we have reached 500.
Mike Victor 416, close clockwise.
Close clockwise, verified.
Mike Victor 412, open counterclockwise.
Open counterclockwise, verified.
Mike Victor 416, open counterclockwise.
Open counterclockwise.